Hi, my name is Wendy Reed, and I teach high school math, and today we're going to learn a little bit about proving triangles congruent. First, the word congruent means same or equal. For example, if one angle has a measure of 35 degrees and another angle has a measure of 35 degrees, then they are congruent because their measures are equal. So, in order for two triangles to be congruent, everything has to be congruent. All corresponding sides and all corresponding angles. But we have actually smaller ways to prove triangles congruent. And there's 5 of them. We have side, 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 angle, side, angle, side, angle, 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 side, and HL, which only works for right triangles. So, let's look at the first one. Let's say I have two triangles with these symbols. Okay, first of all, these symbols, like you see one symbol here and one symbol here, that means that those two segments are congruent. Okay, then you have two symbols here because these two segments are congruent, but they're not congruent to those two, so you have to switch to two symbols. And then you have 3 here because these two segments are congruent, but not congruent to the rest. So you have to sometimes increase the number of little symbols you use. So if you look at this, you've got two triangles. You don't really know anything about the angles, but you know you have one pair of sides congruent, 2 pairs of sides congruent, 3 pairs of sides congruent, and that is SSS. So that makes the triangles congruent. So as long as you have at least 3 sides congruent, you can prove the triangles congruent. Let's look at another set. Say I had this picture. Okay, if you look at this picture, you've got 2 triangles, but they're connected. Okay, if you look at the top triangle, you have 3 sides. If you look at the bottom triangle, you have 3 sides. But this middle one is actually part of both triangles. So if it's part of both triangles, then it's congruent to itself, and you can put some symbols on it. So now you have 1 pair of sides congruent, 2 pairs of sides congruent, 3 pairs of sides congruent, and you do have side, side, side. So the triangles are congruent, and we write a congruent statement. And what your congruent statement is you just you say triangle dot 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 is congruent to triangle dot dot dot, and you use proper letters. So we're going to say triangle ACB is congruent to triangle. Now the order of the second letters matters according to how you did the first one. If I did ACB, on the second one I have to do ADB, just to follow the same order of letters. Now if I had done ABC, on the second one I would do ABD. But the order of the letters does matter when you're doing your triangle congruent statement. And that is side, side, side. So let's go to our second one, which is side, angle, side. Let's change this up a bit. Now, what side, angle, side is, it's a little similar to side, 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 except for instead of 3 congruent sides, you have 2 congruent sides and 1 congruent angle. But there's a trick to that congruent angle. It can't be just anywhere. The congruent angle has to be between the 2 congruent sides. For example, if I put a congruent angle here, and when we do congruent angles, we use what we call arc marks. So it's not a straight line like on the segments. It's actually a little bit of a curve to it. So that means that these 2 angles are congruent. But is that angle between the 2 congruent segments? No, it's not. So that's not the angle we need to be congruent in order for it to be side, angle, side. It needs to be this one because that's the angle between the 2 congruent segments. Now you can see you have side, angle, side, congruent. And then if we put some letters on here, you can do your triangle congruent statement, and that will be triangle ACB is congruent to triangle. And remember, the order of the letters matters. If I did ACB, I would do GIH. So triangle ACB is congruent to triangle GIH. And that's side, angle, side. Let's look at one more example of that. Let's say I have something like this. Okay? Okay? Look at this. We have something called vertical angles. And And vertical angles are always congruent. So anytime you have angles that are exact opposite of each other when they make an X, that means they're vertical and they're congruent. So I can automatically put angle congruent symbols right there. If you look at this figure now, you see side, angle, side. So that is side, angle, side. And we can do our congruent statement, and this one's going to be a little tricky. So if I do triangle GTH, okay, I started with G, which is next to the little 1 symbol, so I can't start with L because L's next to 2. So I have to start with J. So triangle JTL. And that's how we would do our triangle congruent statement for that. So the order of the letters does matter. And that is side, angle, side. And then our third one is angle, side, angle. And angle, side, angle is kind of similar. Similar to side, angle, side, except for the exact opposite. Instead of 2 sides with an included angle, now it's 2 angles with the included side. And again, the included means it has to be between the 2 congruent angles. So let's put some congruent angles on here. Okay. In order for it to be angle, side, angle, it has to be between the 2 congruent angles. And notice I used 2 arc marks here because I've already used 1. So just like with these slash marks, you have to increase the number as the number of congruent angles goes up. So we've got angle, side, angle. So this one is angle, side, angle. Okay. Let's look at another one. Let's say I had something like this. Okay. If you look at this figure, you would think, well, I've only got 1 angle and I've only got 1 side. But remember what we said earlier, vertical angles are always congruent. So I can put some congruent symbols here, and that makes it angle, side, angle. And then if I put some letters on here, I can do my triangle congruent statement. So if we do triangle X, Y, Z, it's congruent to triangle. If we do X, Y, Z, we have to do U, T, Z. So that's how that works. So that's angle, side, angle. Okay? And then we have our next one is angle, angle, side. And that one is really interesting because instead of being, we had the included angle here, we had the included side here. Now it's not in the middle. So it's a non-included side. So we can actually change this one up just a little. Now, where we had this a minute ago, that was angle, side, angle. Okay? Instead of being in the middle, let's put it down here, and that's going to give you angle, angle, side. And that's the difference between angle, side, angle, and angle, angle, side. So it's just the order in which it's placed. Angle, angle, side. That's not the only place it could be. It could be here too, and it'd be angle, angle, side. It wouldn't matter. So that's angle, angle, side. So let's look at another one. Okay, if you look at this one, you say, well, I don't have a side. But think about this. Remember earlier we said that if one side connects 2 triangles, this is actually congruent to itself. So we can put a little symbol here, and we've got angle, angle, side. So this one is angle, angle, side. And then we can write a triangle congruent statement. So triangle VUT is congruent to triangle VUT, so we have to go VWT. And that one is angle, angle, side. And then our last one is HL, and And I want to make another note, they are right triangles only. And the reason is because H stands for hypotenuse and L stands for leg. The only time you really talk about hypotenuse and leg is when you have a right triangle. So, remember, keep in mind, HL is for right triangles only. Now, people tend to think that if they're right triangles, it's automatically going to be HL, but that's not necessarily the case. Just because it's right triangles does not mean it definitely will be HL. But it's a good thing to actually check for that first. So let's look at an example. So let's say I had this. Okay, think about what HL means. H stands for hypotenuse and L stands for leg. And remember, the hypotenuse is always across from the right angle. So my hypotenuse is going to be over here. Now if you look at these figures, does it show the hypotenuse to be congruent? No, so this is not HL. So that's just a good example of how it doesn't have to be HL just because they're right triangles. Okay, if you look at this, you've got a side, you've got an angle, and you've got a side. So this is actually side angle side. Okay, so pay attention to that when you're looking at right triangles. So if I had something else, instead of here, if I have it there, now we've got our hypotenuse and we've got our legs. Now we have HL. So let's look at another example. Okay, we've got two right triangles here. If you look at this is a tricky one. This one always confuses people. Okay, if you look at this, you would automatically think it's HL, but it's not. These are a leg, these are a leg. Here's your hypotenuse, okay? So this is not HL. Again, this is side angle side. But again, if we changed it up, now we can see here's our H, here's our L. So now it is HL, and we can write a triangle congruent statement. Triangle A, B, C will be congruent to triangle. So we did A, B, C, so we have to start over here and do D, E, C. And that is proving triangles congruent.